Hi, and welcome to Blockchain, Cryptocurrency, and Web3 Foundations Module 2. Today we'll be talking a little bit more about blockchain's network and the actors that are on this network, and then the most prominent use for blockchains in general, cryptocurrency. So again, I'll take a note that we'd like you to have some notes at the end of this. We'll be using this in class. So really, what questions come up for you and what terms you don't recognize, please take note of these. And what's confusing or missing potentially in these slides. We'll use these in this week's discussions. So go ahead and grab a good thing to take notes on and we'll get started. So last time we left you with this thought is that once something is confirmed on a blockchain, it's final, right? That it is an open database that we can trust without trusting anyone who's using it. But why is this, right? This is a novel thing. We didn't really go too much into depth. So before we dive too deep into what that question is, we have to know a little bit more about how blockchains are architected in general. So what is a blockchain network and what kind of people and users interact on this network? Well, it's a set of peers, right? And these include nodes, typically, that you'll hear basically anyone who's actually on the network, who's communicating in this blockchain database, specifically communicating around blocks and things that are going on within these blocks. They're called nodes. You can have full nodes and light nodes. We'll get into that in a little bit. And we'll have validators or miners. So depending on the network, you'll hear these terms used somewhat interchangeably, and depending on the context, what kind of mechanisms they use to secure the network will change which term is used pretty much. And these peers on this network provide services for each other and for clients on this network. So you can think of these as things like wallets and decentralized apps, which we'll get more into in the next module. But in particular, these guys might not actually have a lot of the blockchain data itself. They just want to interact with the blockchain in some way. For instance, if we're talking about cryptocurrencies a little bit later, it might be like submitting a transaction. So then, what is a miner or a validator, right? So of these peers, this is again a node on the network that gathers transactions. It groups these transactions into blocks, new blocks that will be generated, and then we'll get into the caveats here, but typically they are paid for the generation of a valid block, meaning that all the information inside of these blocks, for instance, if they're cryptocurrency transactions, are correct and we can prove that they are. And then they will gossip these valid blocks, meaning they're talking to their other peers about these blocks on this blockchain network. And finally, it will store blockchain data and accepts inquiries, accepts any queries that might come about this particular data. But again, all these starred bits are typically optional in the sense that you might not want to run this node and let the public query data about things. But other nodes on this network might need to know things about, for instance, new transactions that have come onto the network and new valid blocks that have been published on the network. So those are more typically available. And then this payment mechanism is definitely typical to the cryptocurrency use case, but it's not necessarily required. So then what is a full versus a light node when we're talking about this? Well, so typically, again, this is just a node on the network that verifies block data and it broadcasts transactions. It can gossip blocks to peers, stores blockchain data, and accepts queries about the blockchain data. So you can think of it just like a miner or a validator node. The one thing that it is missing is the actual production of new blocks. So it does not participate in this. And all of these things are really optional in the sense that are starred here. The difference between a full node and a light node is that typically in the lingo that we use, a full node stores the entire blockchain, all the way from the genesis block, as we call it, the first block that ever existed on the network, out to the most present block that the network is aware of at the moment. Light nodes typically are called pruned, in the sense that they will not necessarily store all of the blockchain data. They will only store data that's relevant to them for their operations, or potentially just a certain number of blocks. For instance, it might only be a few hundred out of the potentially millions of blocks that exist, but just the present ones that they need to operate. And again, so all these things are optional that are starred here. Potentially, you might just want to run one of these that's basically silent on the network and observing the network. So then what is a client? right? You can see in this graphic here, if we have a decentralized network of these nodes, these full nodes, validators, miners, whatever they might be, we can have clients that connect to these nodes, but are really independent of this node network that's on this blind. The block that's operating with this blockchain. They just want to communicate with a node on the network about this blockchain information. So like clients, typically what these things are doing is forming transactions or signing messages. So you can think of this as like, in a cryptocurrency context, signing a message to send funds from one account to another. It generally, though, relies on communication with a node on the network because it is not one. For data about blocks, for instance, if you wanted to know what the balance of a cryptocurrency account might be, and validation. So if that transaction you want to make sure that is actually valid, the client may or may not have the tooling within it to understand if that's valid or not, but it needs to go through a node to make sure that it absolutely is. And transaction broadcasting. So a light client in and of itself typically doesn't know how to gossip amongst the peers on the nodes. So it can only talk to one node on the network directly, and that node is then in charge of talking out to the rest of the network to get that out there in the world. Typically, light clients will have no or minimal blockchain data. So again, much like a light node might have, a light client might store some blockchain data, for instance, like what's your account balance, but that's it. That's the only thing it will actually keep around. The rest, it's totally dependent on the blockchain node that it's connected to for that. A full client is typically just a light client that can be extended with an embedded node. So this is becoming a more popular thing as nodes are getting more and more refined and easier to run, so that your light client can, as a full client, can communicate to the network and operate as a full node effectively, or a light node, whatever you'd like to configure. So all of the transaction signing that you might need, you can do on your own. Connect to the network directly. So this kind of gives you a little bit more of an outlook as to what this generally is on a cryptocurrency network, for instance. You'll have users that are on their devices, and these are typically light clients, and they might store keys. So we talk about public and private key cryptography. This is where you would store those private keys and have the ability to interact with those in a convenient way. So wallet softwares would be an instance of a light client, in which you're really just interested in what your account balances are and the ability to send those around. And those will be broadcast directly to individual nodes. And you get to select these as a user. Potentially, this is already baked into the software that you have, or it might be selected at random. Or as we're seeing more and more full clients that actually are node in and of themselves, they'll be able to gossip to a variety of dynamic peers. So how do we achieve consensus? Right? A consensus mechanism really ensures that all nodes share the same version of truth. So as we're building this blockchain all the way back in history up to the present moment and deciding on what the next block should be along the way, we have to make sure everyone agrees on what that should be, right? And there are many ways to achieve this. It's been in computer science a very tricky problem, and it was pioneered by Satoshi, as you'll read in the white paper this week, with proof of work and mining specifically. So this is a way to get distributed consensus even in the presence of adversaries who might want to be telling you a different version of truth, and also to make it, as in proof of work might imply, very difficult to actually produce valid blocks. So in this case, because of the difficulty to come to the next state that the entire blockchain network needs to progress to, it's very unlikely that multiple versions of this state will be produced that are valid at the same time. And when they are, there's mechanisms to go around deciding how that is elected, what is the next real block that should be there. And with proof of stake, this is another mechanism that's typical now in the years of 2021, right? That we're seeing this just start to develop. This is an alternative that poses that proof of work might be too energy intensive and it has its problems and things like this. So instead of having it very difficult to produce blocks, it's very easy to produce blocks. But the idea here is if you're working correctly, things are being produced valid in the structure that we've decided upon, the protocols that we've decided upon, you're rewarded. And if you're caught doing things that are incorrect or invalid, then you'll be punished. So instead of all reward, but it's very difficult, we'll have a system of benefits and demerits that will help make sure that everyone comes to consensus in a similar way. Last one I'll mention is Byzantine fault tolerance, where here this is kind of underpinning both proof of work, proof of stake, and many more methods that are out there in the world. But in particular, it's trying to address this problem that you might be surrounded by peers who are all adversaries trying to lie to you. So if we know that there could be bad actors who are trying to manipulate the information and the source of truth around this consensus, how do we go about ensuring that we have the truth, even when there are bad players there? So, what is cryptocurrency? It's a blockchain that is storing financial transactions. Specifically, the novel thing here is that it's self-sovereign. We use public key cryptography, as learning about in the last module, that we use to access these funds. So this is really the novel aspect, is that typically when you have digital financial transactions, we have a third-party intermediary who is effectively storing the ledger and validating this ledger on your behalf, right? So banks do this, payment services like PayPal or Venmo, they do this. But here we have a method that we have this network to facilitate direct peer-to-peer or P2P. No third-party intermediary is needed. So in this case, if the blockchain exists, is out there, and is willing to accept and process these transactions, then there really is no way to censor this. In the sense of a bank could, for instance, shut down transactions that they find illicit or totally revoke your account, right? So in a blockchain network, there is no authority of this network that can censor or potentially invalidate accounts on the network. So all of this, the only way in which we can progress forward is through validating private keys, right? And if we attach some incentives, we'll find out a little bit more in the readings this week. For instance, paying a miner to process our transaction, just a little fraction of this. There's no reason that one of the nodes on the network wouldn't decide to process this, and eventually this will come to fruition without, I should say, even in the presence of adversaries who wants to stop us. So then, once consensus is reached, the ledger is final. That's the real thing to take away here. It's an open database that we can trust if it's costly to cheat. In fact, if it has to be more costly to cheat than to play by the rules of the network. All right, and that's it. That's it for Module 2 anyway. So we took a little bit deeper look at some of the actors who exist on a blockchain network and specifically talked about cryptocurrency. And videos and readings in this module really expand on those incentives. So how do we make sure that those people who are rewarded and punished, how do we go about doing that in a way that we make sure that this network is really permissionless and censorship resistant, even if we have bad actors who would like to stop us from interacting with this network. And then finally, in next module, we'll take a little bit more of a look at abstractions that are built on top of blockchains. So smart contracts that you might have heard of before, as well as dApps, decentralized applications. Typically, these are in the context of cryptocurrency. So keep that in mind as you're going through. All right, thanks, guys.